Modernage MCQs Unit 14 Electromagnetic induction Part 2. A flux of 3 Weber in a coil of 10 turns is reversed in 0.3 seconds. The EMF induced in the coil is option A 50 volts, option B 100 volts, option C 150 volts, option D 200 volts. The key is 200 volts. Therefore, the correct option is D. Reason: the induced EMF in the coil is epsilon is equal to N delta phi or delta T, which is equal to 10 into 3 minus 3 divided by 0.3 R. Epsilon is equal to 200 volts. Hence, the induced EMF in the coil is 200 volts. The statically induced EMF is found in option A dynamo, option B generator, option C transformer, option D alternator. The key is transformer. Therefore, the correct option is C. Reason: the primary and secondary coils of transformer are stationary. The flux in primary coil links with secondary. The change of flux in primary is due to alternating current AC. This change in magnetic flux induces EMF in the secondary, which is statically induced EMF. Hence, the statically induced EMF is found in a transformer. The SI unit of self-inductance is option A volt per ampere second, option B volt per ampere per second, option C per volt per ampere seconds, option D volt ampere seconds. The key is volt per ampere seconds. Therefore, the correct option is A. Reason: the induced EMF in a coil itself is epsilon is equal to L delta I over delta T, or L is equal to epsilon divided by delta I over delta T. If induced EMF epsilon is equal to 1 volt and the rate of change of current delta I over delta T is equal to 1 per ampere per ampere seconds, then the SI unit of self-inductance is volt per ampere seconds. It is called Henry. Thus, 1 volt per ampere second is equal to 1 Henry, which is denoted by 1 H. Hence, the SI unit of self-inductance is volt per ampere seconds. Square bracket M, L power 2, A power minus 2, T power minus 2 is the dimension formula of option A conductance, option B inductance, option C reactance, option D impedance. The key is inductance. Therefore, the correct option is B. Reason: the square bracket M L power 2, A power minus 2, T power minus 2 is equal to square bracket M L power 2, A power minus 1, T power minus 3 into square bracket A power minus 1 T is equal to volt per ampere per second, and it is written as H and known as the Henry. It is a SI unit of inductance. Hence, square bracket M L power 2, A power minus 2, T power minus 2 is the dimension formula of inductance. Note: the SI unit volt per ampere per second written as Henry, and dimensional formula square bracket M L power 2, T power minus 2, A power minus 2 of self-inductance and mutual inductance is same as for inductance. The inductance of coil depends on Number 1, shape of coil. Number 2, permeability of medium. Number 3, turns of coil. The option A, 1, 2, option B, 2, 3, option C, 1, 3, option D, 1, 2, 3. The key is 1, 2, 3. Therefore, the correct option is D. Reason. Anything which affects magnetic field affects the inductance, the shape, the number of turns, and permeability of core affects magnetic field B, which is equal to mu n I, where mu is the permeability of core, n is the number of turns per unit length, and I is the current. Hence, shape, number of turns of coil, and permeability of core affects inductance. The eddy current in a conductor is due to option A, dynamo EMF, option B, battery EMF, option C, thermocouple EMF, option D, induced EMF. The key is induced EMF. Therefore, the correct option is D. Reason. The eddy current in a conductor is due to induced EMF. According to Faraday's law of electromagnetic induction, the EMF induces in a conductor by change in magnetic flux, which aligns the motion of electrons. This motion of electrons produces eddy current. Hence, the eddy current in a conductor is due to induced EMF. An electric fan converts option A, thermal energy into electrical energy, option B, magnetic energy into thermal energy, option C, electric energy into mechanical energy, option D, mechanical energy into magnetic energy. The key is electric energy into mechanical energy. Therefore, the correct option is C. Reason. The electric fan is a motor. A motor converts electrical energy into mechanical energy. Hence, a fan converts electric energy into mechanical energy. A loop of wire of 5 ohm moves in a magnetic field. The power dissipation is 0.2 watts if the induced current is option A 0.2 ampere, option B 0.5 ampere, option C 0.8 ampere, option D 1.0 ampere. The key is 0.2 ampere. Therefore, the correct option is A. Reason. The power dissipation in a resistive circuit is P is equal to I square R. Therefore, I is equal to P divided by R square root. Or I is equal to square root 0.2 divided by 5, which is equal to 0.04 square root, which is equal to 0.2 ampere. Hence, the induced current in the loop is 0.2 ampere. A loop of wire of 10 ohms moves in a magnetic field. The energy consumed is 0.4 joule per second for the induced EMF. Option A 10 volts, option B 4.0 volts, option C 2.0 volts, option D 1.0 volts. The key is 2.0 volts. Therefore, the correct option is C. Reason. The energy consumed per second is power dissipation. Therefore, P is equal to epsilon square divided by R, or epsilon is equal to P into R square root, which is equal to 0.4 into 10 square root, which is equal to 4 square root, which is equal to 2.0 volts, because P is equal to 0.4 joule per second is equal to 0.4 watts. Hence, The induced EMF in the loop is 2.0 volts. The magnetic flux is changing through a rectangular coil of 1 turn. The energy loss is at a rate of 40 millijoules per second if induced current is 0.1 ampere. The resistance of coil will be option A 40 ohms, option B 10 ohms, option C 4.0 ohms, option D 0.1 ohms. The key is 4.0 ohms. Therefore, the correct option is C. Reason. The power dissipation in a resistive circuit is P is equal to I square, or therefore the resistance of the coil is R is equal to P divided by I square, which is equal to 0.04 divided by 0.1 whole square, which is equal to 0.04 divided by 0.01, which is equal to 4.0 ohms. Hence, the resistance of the coil is 4.0 ohms.